It is a real pleasure to be here today. I will be talking about a new technology for speakers, so audio reproduction, in particular micro speakers for portable devices based on silicon technologies. So at Usound, we are developing a class of speakers with new properties. We have two generations of speakers right now available. The first one is the one top left that you can see, ADAP and Akelus. And the new generation is the Connemara with around form factor. These new micro speakers are fabricated using semiconductor technology. So we are using silicon and we are using microelectronics assembly processes to actually assemble the parts. This is bringing in some new features in terms of thickness of the devices, lightweight, so the weight of the device. They are reflow solderable, so very easily integratable in digital devices. And they produce very low vibration and no heat during operations. The devices are qualified under standard ESC and JEDEC. And as you see, we have various form factor from the quadratic one, the rectangular one, and the circular one comes in two diameters, 6 and 10 millimeters. Typical applications are TWS and portable devices. As you see on the left, some measurements, acoustic measurements from our data sheets. So these objects can reach 120 dB and above in a 711 coupler with lower level of THD. But I will talk about the application a little bit later. Let me step in with some historical information about how MEMS microphones entered the market and actually had a big impact on it in the last few years. So, of course, until early 2000, the microphone market was basically based on electric microphones, and the MEMS microphones took a long time to actually establish themselves in the market. But then, as you see, the growth in terms of both revenue and quantities have been quite spectacular. But still, the electret microphones have maintained their numbers. Just the MEMS microphones did basically enabled new applications, and through that have been able to grow in the market. There was two factors that have been decisive for them to succeed and to win designs into devices. It has been the fact that they are reflow solderable, so SMD elements like every microchip that is used in modern digital devices, and they are already also very thin in form factor. So we are following the same path for MEMS loudspeakers, offering the same advantage plus a few additional features. So here a brief summary of what we develop at Usound. We don't only develop the speaker technology, but we are heavily involved in developing their applications, typically in form of design references or design kits. And so you can see we have available in-ear headphones for so both wired and wireless, so TWS. And we are investing a lot of efforts also in wearable, in particular for smart glasses. There are applications also in array solutions for smart speakers and audio for gaming and VR. And of course, from the electronic side, we are also offering a dedicated piezo amplifier that have some specific features, and in particular is a very low power consumption, very efficient. Basically, what we try to do in this space is to eliminate electromagnetic fields and reduce size and weight of the transducers, and with that, the overall system footprint of it. The sound quality is comparable to available technologies with some differences, but what we really create is to have an SMD component to be seamlessly integrated into digital modules with microelectronics manufacturing technologies. So this, in our opinion, is as disrupting as MEMS microphone and LEDs. So it's a new innovation playground with a lot to come as we are at the beginning of the roadmap. To give you a brief impression of how they are built, basically we do have a substrate with all the electronic interconnections. We have a MEMS motor, which is a silicon chip providing the mechanical movement to an acoustic membrane. The membrane is glued on top of it using microelectronics pick-and-place machines, and we typically add the cover with an acoustic mesh on top of it. These results in devices which have very specific characteristics, and in particular, compared to the voice coil loudspeaker, the response of the piezo elements that are driving the membrane is very fast. It's much faster than a voice coil, and is also more precise because it works like a linear motor, and the signal corresponds to a specific position, means the speaker can work also at very low frequency with a very precise movement, giving a specific bass response. These objects are very wideband, so they go from 20 Hertz or below to the ultrasound. So they are as big as balance armature objects, but they are much more wideband than that technology. They are very light, as all the components used are very light in nature, and very thin, so around 1 millimeter, as we use silicon technologies, which is a planar technology, thin film technology, and low power. And in particular, as always when it comes about MEMS, so silicon sensor or actuators, they are very well suitable for array configuration. So to use more than one, actually using many. And we are doing some nice experiments with that I will show later. And the last 2 points is the integration of these devices into digital systems. So there are no electromagnetic fields, no heat generation, and most importantly, they are reflow solderable. So you can use the same technologies as for standard microchips. The last one is the very tight specifications that we can assure thanks to the silicon supply chain. Basically, all the processes involved are around 1 order of magnitude more precise than the processes used for standard voice coil loudspeakers. So we can assure better quality, better reliability, and scalability in volume, including high yields. Here is an example between a typical receiver for mobile phone and a MEMS speaker in terms of heat production. So you can see on the left side, of course, the voice coil will heat up when driven, and the MEMS speaker do not produce any heat. This is because of the concept, underlying concept the MEMS speaker is basically behaving as a capacitor and is not dissipating any energy through heat. Another aspect of the technology, as I said, is the reflow solderability. Here we see the assembly line of Usound and some of the tests that we have done to demonstrate the survivability of the elements to the typical reflow soldering temperature profile. And this is something that standard loudspeakers, micro loudspeakers cannot do because of the issues in the membranes and in the magnetic materials that they use. They will not sustain such a temperature. An interesting fact about the MEMS is that the membrane that we are using has a much less demanding specifications because it doesn't have any mechanical function in the speaker, as the MEMS is already mechanically stable enough. So we can basically use materials that survive much better to harsh environments and to temperature. And here an example of how to integrate our MEMS speaker into a typical TWS design. So on the left, top left, we have our Connemara speaker, and on the right, a typical 6mm TWS speaker. So the first major difference is the thickness. The typical 6mm speaker is around 4 or 5mm thick, and the MEMS speaker is much thinner. So this means there is more space available, but not only that. So the MEMS speaker is around 10 times lighter than a traditional speaker. And weight, when it comes to TWS, has an impact because wearing for longer periods earbuds can be uncomfortable just for the weight on your ear. And the same can be said for vibrations. So we have 5 times less vibrations because the moving masses, so there is no coil, the moving masses are much lighter. And same here, this is about comfort for the user. And for staying into the TWS space, these are some of the concepts that we are implementing for creating an integrated module into the tip of the earphone. Basically, we use the tip of the earphone, which is an element that can be quite standardized into the industry because it must fit the anatomy of the human ear, and so can be standardized to a certain extent. And in this tiny space, we can pack the speaker, but also easily integrate a feedback microphone on top of it. You can see on the top image, you see the round speaker and a MEMS microphone on top of it, connected via a rigid flex PCB. And all this fits into the module. But we are also integrating other elements like acoustic meshes, of course, but most importantly, electronics components. So we can integrate on the rear of the speakers, driving elements, wireless connectivity elements, but also very interestingly, sensors. So this module can become a sensor hub for high-end TWS, typically healthcare sensors that can be integrated in that place. So all in all, this will be a development that will provide a module with high water resistance and dust resistance characteristics, high shock robustness, and a lot of integrated intelligence for enabling more features and reducing space in the final products. We are seeing a lot of interest from many cellular, so smartphone manufacturers on this type of concept, because they are all trying to put TWS headphones into the bundle with their telephones. And one of the issues that they have is scalability and volumes. So you don't want to have too much hand labor to produce that volumes. And with this concept, we can offer them the level of automation that they need, including the quality and repeatability of the processes. So we see a lot of interest on this type of solutions. And regarding the audio amplifier, so this is a digital interface, I2S audio. We have spent a lot of time and effort to develop an energy recovery system in order to optimize and reduce power consumption. And we've been successful in that. This is one of the major barriers when it comes to this type of transducers. And we have a few functions here, including equalization and optional pre-distortion algorithm in order to optimize the output, the audio output. Another product that we are very excited about are the Fauna smart glasses. So Usound have worked on integrated audio into glasses since many years now. And we have decided to actually start a new brand and commercialize this product on our own. But we are also following a B2B path on this. So we are open for cooperations and putting our know-how available to B2B customers. But what we want to demonstrate with this is that audio in smart glasses can have a big impact. In particular, these objects are amazing for telephone calls. And in these times where we are using teleconferencing a lot, this is very helpful. So basically, you have the full experience of a stereo audio without wearing an earbud. And if you have to talk for long times or using for long times, this is a good advantage. Of course, the glasses also have integrated MEMS microphones with beamforming, so there are both. The communication goes in both ways. What we do here, so we have developed specific audio modules with the acoustic transducers, the electronics for driving it, and the audio design in the same shell. And one thing that we have developed is the use of basically an acoustic dipole in order to reduce the amount of sound that is leaking toward the ambient. So if you look on the right, this is a simulation with a speaker just put near the ear, and by using a dipole concept, we can limit the amount of sound that is leaking in the environment, and basically then concentrating the sound around the ear of the user. So in a normal case, in a normal office, at 1 meter apart, you would not be able to hear what I'm hearing. Of course, in this space, there are a few other competitors, actually big brands like Bose and Huawei and Amazon. We have done some homework here to benchmark our solution with other solutions. And we see, in our opinion, our solution is the best fit for matching industrial design and power consumption. So we see what these two other brands have done is very different. So Huawei is using a very tiny speaker, with the cost of sensitivity. And Bose is using a very large speaker with very good sensitivity, but at the cost of the industrial design of the object. So we are in between. Our module is small enough for doing an appealing industrial design, but also have a decent sensitivity and so power consumption. There are many other things that that Usound is doing with MEMS loudspeakers. Here you can see on the left the Proteus smart speaker that we have developed. This is a speaker where you have a woofer in the box, and you have three elements with tweeters, MEMS tweeters, radiating 360 degrees. So the sound is amazing, but most interestingly, this is an opportunity for doing better and more innovative industrial designs for smart speakers. Other things we are doing is the development of 3D sound headphones, so Q-preserving headphones, including elevation. And this is by using arrays of speakers carefully placed around the ear of the listener to actually have a sound source physically directed in a certain direction. And another field of application is automotive, although this will come a bit later, when we can produce modules that are very thin and can be integrated into the car cockpit, so automotive application for personal audio. So thank you very much. So this was my presentation, and I'm open for questions if any.